and welcome to today's webinar, GVERSE XSection, the best just got better. Last year we introduced GVERSE XSection as the GeoPlus version of the beloved XSection. Since then, development has been hard at work to make GVERSE XSection even better by adding new functionality and improved performance. Before I go over the difference between today's GVERSE XSection and last year's version, let's remind you of what GVERSE XSection is. GVERSE XSection is completely backward compatible with XSection. In other words, you can launch any saved XSection cross-section within the GVERSE XSection from either a saved file or an XSection layer in GeoAtlas. GVERSE XSection supports all of the XSection workflows so that the learning curve is essentially flat. You can interpret cross-sections in either unmodeled or modeled mode. This means that you can do your cross-section interpretation just like you do in XSection for picking tops or intervals, or you can activate the topology engine and create on-the-fly surfaces as you interpret. In model mode, the surfaces can project over wells that have no picks. We call these projected surfaces predicted tops. These predicted tops can aid in placing hard pick points within complicated stratigraphy. GVERSE XSection is integrated with both GeoPlus Map and the 3D view, so that the cursor tracking in one view is supported in the other two views. GVERSE XSection has an enhanced user interface that supports many more features and functions not available in XSection. Multiple GVERSE XSection cross-sections are saved to the cross-section tree within GeoPlus Map for easy access. Now let's see what's new for GVERSE XSection for the 2023.2 release. A Log Data Readout window is available for displaying the curve values in a well at the cursor position. There is now more control on visibility of wells within the cross-section. Wells can be hidden without being removed from the cross-section and easily turned back on from the Wells tab. In unmodeled mode, tops can be snapped to an existing top to create sealed unconformity pinchouts or fault cutouts. The line of section can be defined along well surface locations or bottom hole locations, making visibility better for deviated or horizontal wells. The Shift keyboard key can be pressed to activate the vertical exaggeration function of the center mouse wheel. Raster images registered to a well can be interactively added to a presentation template containing image tracks. Additional features in the 2023.2 version are: it is now possible to transfer cross-sections and templates among other GeoPlus interpretations with the new interpretation browser. The map view within GeoPlus supports creating, updating, and editing major GeoAtlas layers. Other enhancements include the ability to select more than one well on the map to add to the cross-section line of section. A new distance measuring tool is available in the 3D view for measuring distances, azimuth, and inclinations between 3D objects. As always, we look for ways to improve performance throughout the system. Now for the demonstration. Now we'll start with a workflow that's familiar to everybody. I'm in GeoAtlas. I'm going to make a 3-well cross-section. So we'll go to cross-section, define cross-section, and we'll do it well to well. Now in the past, when you double-clicked, it would automatically send it to XSection. Now we have a choice here. We have an option to either go to XSection or to GVERSE GeoPlus, the environment in which GVERSE XSection lives. We'll create a new interpretation in GeoPlus. An interpretation is like a saved session. It keeps all of your configurations saved, so the next time you open it up, everything is already preserved for you. It will make the cross-section full screen. Now, I'm not going to focus on what you already know about XSection because that's fully supported with GVERSE XSection. What I'm going to do is mainly focus on what is not available in XSection that is only available in GVERSE XSection. We'll start down here at the lower left with these tabs. We'll start with the Wells tabs. This gives you a well list that you can add to. You can remove wells, you can move them up, move them down, reverse the order, insert before or after. You can also flip the well orientation. But what is nice is you can actually add more information to the well list. So if you don't have all the API numbers memorized, you can put the well names or operators on there to make them more recognizable. The next tab is the Templates tab. This would be where you would have saved cross-section templates. We don't have any yet, but we will make one in the workflow. The next tab is the Surfaces tab. It presents to you the currently active stratigraphic column. We'll go ahead and turn them all on. And we'll zoom into the area where they're displayed. Next to the Active Well tab. This is a very useful tab for getting at your presentation templates that are either going to be in your project area or your system area. So you can interactively add presentation templates to one or all of the cross sections. In this case, we're going to take the clay minerals.prt. I'm going to set that as the default template. And close this down. Another very useful feature of the Active Well tab is if you click on the well, it puts a red outline indicating this is the currently active well with a focus. And it will present to you all of the available well curve sets and the curves that belong to them. If you have a TGS account, you can interactively add either raster or vector wells to each well in the cross section. Plus, if you have depth registered raster logs, you can interactively add those to the templates that have raster images. The last tab is the ISOMAP tab that allows us to add ISOMAP layers. In this case, we're going to put down the Basal Atoka ISOMAP layer, and we will zoom to width. Now, this is an ISOMAP layer on an equally spaced cross section, therefore it is going to be scrunched up. So we'll just go ahead and turn that off for visibility. Next, we're going to look at the Wells Logs dialog box, which is very familiar to you, and it's very similar in GVERSE XSection to XSection. In other words, there's the clay minerals.prt that we added interactively. You can add user-defined equations to the models. Go to the Layout tab, and we're going to change the layout, maybe make it a 4:1 vertical exaggeration. Depth interval will be 6,000 feet measured depth. And at the well postings, we can now draw the curve scales at the top of the cross section that will stay put no matter what zoom scale you are or scrolling. We're also going to add a few more well postings on here. We're going to add status, and down here the well name, and move them up to the header area, and then change the font for all of those so you can see them a little bit better. And OK. Notice now when I use the mouse wheel to scroll up and down, the curve scale stays in the header. Now if the postings, the well postings at the top of the header are too small, you can hover your mouse over it and we'll give you a little tooltip of everything that you've configured for the header. Now if you have too many items in the header, you can truncate them down to 5 with this little button here that limits only to 5 lines of information in the headers. Another thing that we've added for 2023.2 is the ability to use the Shift key on your keyboard and the mouse wheel to interactively change the vertical exaggeration. Also, if you hold down the Control key on your keyboard, you can change interactively the zoom scale with the mouse wheel. Another nice feature is the data readout. I turn that on and hover over a particular well and move the cursor up and down. you can interactively view the curve values for all the curves presented on that template. You can also interactively, with the right mouse click, hide the well in the cross section, but it does not take it out of the well list. So here's the well list with the eyeball poked out. To add the well back in, simply unpoke the eye, and there it is. And then finally, the F7 key will toggle between edge to edge or center to center mode. So let's go ahead and do some picking. Now we're in the Barnett in North Texas. The orange here is the basal Atoka. The dark green is the upper Barnett. The light green is the Barnett maximum flooding surface. The dark blue here is the basal Barnett, and the purple color down here is the Canberra Ordovician Ellenberger. Let's go ahead and select the basal Barnett and hit the space bar on the keyboard to flatten it. Now we're looking here at the Barnett between the upper Barnett and the Ellenberger. And right here between the maximum flooding surface and the basal Barnett, you've got some buildup, some competent components, which also have a lot of storage capacity in its native porosity. So we'll go ahead and pick that as our active surface. So we'll click on Surfaces. That's our Barnett target surface. And we'll turn on our picker just like you would if you were in X section. And we'll make the pick right there. Now we also have the ability to select wells, make that the active well, then hold the mouse down, the left mouse button down, and drag it next to the next well. And with the log slipping tool, we can slip the entire log. So you can do correlation not just in the area you're interested in, but correlation up and down the log display. So we'll put it right there, and come back here to the Barnett target, turn on the picker again, make the pick, and use the F6 key to put it back in the correct order. Now I'm going to go ahead and pick the Barnett target in the last well, but I'm going to use not only the picker and the correlation tool, but I'm going to turn on Quick Pick mode. Quick Pick mode allows you to take your cursor, your picker, and pick annotations anywhere on the log. So we're not really quite sure exactly where that would correlate. So we now have multi-level undo and redo of that annotation. Nothing's in the database and nothing's in any kind of model. So until we're satisfied with where we want that pick to be, we can move them back and forth, delete them, or do whatever we want to with them, drag them to a new position. If I like that location, I just come up here to the Quick Pick menu and save the Quick Pick, and there you go, you made the correlation. Now there are some new features for the intervals also. So we're going to turn on the intervals menu. Again, this looks just like it does in X section. And we're going to add a pay interval between the maximum flooding surface and the basal Barnett and the basal Barnett and the Ellenberger. Now within this interval, we now have new interval attributes. So we're going to add some interval data fields. And we're going to call this interval field the shale interval attribute. We're going to keep it numeric. You have 3 different types, numeric, text, and date. Keep it numeric. And we're going to add another one. We call this competent. Again, it's going to be numeric. So now we have 2 interval data fields, interval attributes. For this one, looks like it's all shale, so we're going to give that a numeric value of 1, or true, and a competent component of 0, or false. Click on the next interval, go to the interval data, and then for this one, the shale component is going to be 0, and the competent component is going to be 1. Now then I'm going to make this the active well by selecting it. And then we're going to go open up Wellbase and look at what we've added to the Intervals tab. And there for the Intervals tab, you see we have the shale for those 2 intervals, 0 and 1, and the competent attribute 1 and 0 for the intervals. Now coming over here, we're going to open up GVERSE Petrophysics and look at those interval curves. Let's make sure we have the model turned on. Slide down to the base where everything is happening. And up here under the data group, I'm going to go to the interval curves. We're going to turn on view interval curves, and we're going to add those two new pay interval attributes, competent and pay. Now that they're added, we're going to add a new track to put them in. Make it a linear track. Let's add a new curve. We'll put the competent one on first. Change the scales to make it a little bit easier to see, and maybe the attributes to make it easier to see. Thicker, and maybe make that orange. So there's your interval attribute curve. You want to add the other one, the shale one, the pay shale one. Then we're going to switch the scales to make it easier to see, and the attributes, make it dark green. So there you have interval attribute curves that can be used on the template. You can make area fills with them, and also you can use them in your user-defined equation set as maybe limiters for looking at different intervals that you want to work with. Let's go ahead and minimize both Petrophysics and GeoAtlas. And let's go ahead and hide the intervals right now. And we're going to save the layout as a template. But first it's going to say, do you want to change the interpretation? In other words, do you want to save the session, everything we've done so far in the session? Yes, we do. And you can give it a name. It comes up with my name. We'll just keep that. You can put your initials on there if you wanted to. And we're going to call this template our correlation template. There we go. And on the templates tab, now we have the correlation template. And we're going to make that our default template. So next time you define a cross section, it will launch pre-configured with this template attributes. Okay, let's change gears a little bit and look at the integration with GeoPhysics. So we're going to change the layout. Change the template to something a little simpler, maybe gamma ray with a fill. We'll go to the layout and we will change the type of cross-section to a proportionally spaced. Change the horizontal scale and also the vertical scale. And come up here and zoom to width. Now we are integrated with GVERSE GeoPhysics, and we're going to look at the seismic options. I currently just have one geophysical interpretation here, but this will be the list. It's a 3D survey. I have my choice of any of the registered volumes in that interpretation. I can add depth converted horizons and faults to the cross section, geobodies, and also change the display. So we'll just keep it configured like this and turn on the display. So there you have your depth converted seismic backdrop presented on your cross section. Okay, now let's get to the geomodeling. Let's turn on the model, and this is going to be a surface-based geomodel. And it's going to present to us the geosurface model properties. Again, this is going to be your active stratigraphic column. We'll go ahead and turn them all on. Now, by the default, the source of the well data is coming from Wellbase. Now, I have a surface I created here called Atoka from SV, my seismic volume. And we're going to make it sourced by GVERSE GeoPhysics. So we'll go ahead and get the B-shell interpretation. There's the smooth Atoka horizon, and there is the volume I picked it on. Under surface constraints, we're going to hang the conformance relationships based upon that 3D Atoka from seismic volume survey, and then hang everything else on the base of Atoka. So it's going to be conformable from the seismic surface down through the base of Lautoka all the way down through the Ellenberger. There you go. Next we can do a thickness map. We're going to do a Barnett thickness. From the upper Barnett to the Ellenberger, and you can do them as either isocore or isopac. We're going to keep it as an isocore. And you could add zone manager attributes also as a property map on here. I don't have any, so I'm not going to do it on this, but we could have done that. Go ahead and click OK. Now back to the Surfaces tab, we need to turn on now the actual geomodel surfaces. Now no geomodeling attributes have been added yet, but you'll notice that the base of Lautoka up here has some character to it, so obviously it has some interwell points on that surface. Now let's look at the map. Now there is an integrated map within GeoPlus. GVERSE XSection lives. So let's go ahead and we'll turn on the surface structure. So there's the Barnett target. Now it was picked in 3 wells, therefore 3 points to find a plane. Now we are also backward compatible with GeoAtlas maps. So let's add a GeoAtlas map, but the same one we started with. It will also be backward compatible with saved cross-section files. So we're going to go ahead and add this vertical wells X-section cross-section. So here it is, and if I close it, it is put into the cross-section tree right there, the vertical wells cross-section. I could open it directly from there. Now, before we turn on the 3D modeling, let's put everything side by side so you can see it happen all at once. So let's just put it right here and make it a little bit smaller so I can get the cross-section on there. Get the cross-section on there. Slide over a little bit there. Now we're going to turn on the conformance and update the surface geomodel. Notice now all these surfaces are conforming to the depth converted base of Lautoka seismic horizon all the way down through the Ellenberger. And over here on the map, you'll see that our target is also conforming to the Lautoka from my seismic volume surface. Now over here in our cross section, the base of Lautoka is an unconformity, and we do have some unconformity squiggles on here. A little hard to see. Well, fortunately we have control over the visibility by changing the height and the periodicity of the squiggles. Makes it a little bit easier to see at your zoom scale. In addition, we are fairly backward compatible with any depth converted seismic geobodies. In this case, I've got the Barnett seismic geobody displayed on the cross section. Now let's return to the map. Go full screen. Notice all of the GeoAtlas layers here are turned on. Let's go ahead and turn off the satellite image. Let's add some color to the Barnett target. And we'll go ahead and turn on the scale bars so you can see the subsea depth. And we're going to put the Barnett target surface at the bottom so you can see all of the other layers on top of it. Now, in addition to the Barnett target surface, we also created attribute maps of the Barnett thickness. Now, these surfaces are all created on the fly with triangulation and minimum curvature smoothing. So if you change any interpretation pick in a cross-section or interwell point, all the maps, the surface maps, the thickness maps, any attribute maps will be automatically updated. So let's go back to our Barnett target and continue. Now we've been working in a 2D map and a 2D cross-section, but we're within a 3D environment now that we've turned on the topology engine. So let's look at the interpretation in 3D. So from the Home tab, I'm going to open the 3D view. Now any open cross-section is automatically a fence diagram. So here is our open 3-well cross-section. Let's increase the vertical exaggeration, make it a little bit easier to see it. You can see I've got my surfaces on there, my depth converted seismic, and my 3 wells. Well, let's start adding objects to the 3D view. So we'll start out with the Barnett target. There's the Barnett target. We go to the properties. We can add contours. We can add GeoAtlas layers. We'll go the land grid, culture, and Texas polygons. We can also edit the cross-section wells. So we're going to show some well data. The surfaces from the Ellenberger up to the base of Latoka. For the logs, we have a gamma ray log, and we can affect its properties. We change from a blade view to a lathe view, make it easier to see it. We can add the map image to the bottom of the 3D view. We can add depth converted geobodies. So there's the Barnett depth converted geobody on the 3D view. And finally, we're going to add an isomap layer. We'll do the Ellenberger this time. So now let's finish up by putting the cross-section next to the map and the 3D view. And you notice that the cursor is tied to the cross-section, the map, and the 3D view. So wherever you move it on the cross-section, within the map, and also within the 3D view, the cursor shows up in the other 2 views. I hope you agree that GVERSE XSection brings a lot of new value to the XSection user. Remember, if you are up to date on your maintenance, you have all the functionality I've shown you up to the surface modeling, and if you currently have a GeoPlus license, you will also have the surface modeling feature, block diagrams, compute length and percent of wellbore and zone features. If you have a Smart Strap and Planner license, you'll have 3D geosteering and well planning utilities respectively. Thank you for attending the webinar, and I hope you have found this webinar informative and encouraging to try the new GVERSE XSection in your workflows.